Hi guys, welcome to chapter 5 of this video tutorial series. In this chapter we'll be discussing how to fetch data from more than one table. We'll be starting our discussion with constraints. We'll jump into relational databases and then we'll see how we can fetch the data involving more than a single table. So the first topic for this video is constraints. So whenever we are inserting any data into any table, there are certain rules that we can impose on how we want to insert the data. So these rules are nothing but our constraints when we talk in database terminology. So there are basically four main constraints, and these are primary key, default, check, and then last foreign key. So let's start with primary key. So whenever we insert any data or whenever we have any data into a table, there should be a column or a field which will help us identify a particular row in that table. If we talk about real world examples, in any organization, all of the employees are given a unique employee ID so that you can identify all the other traits of a particular employee with the help of employee ID. Similarly, if you are in US, you are given a social security number so that with that number they can identify all your details. And if you are in India, you are given an Aadhaar card or the Aadhaar number, which will help identify all of your details using a single number. Similarly, we have a primary key in order to identify the rows in a table, and that is why we use the primary key. Primary key makes the process of fetching the data from the database a lot easier. If you don't have a primary key in a table, if you want to fetch the results, then you'll have to specify almost all of the columns, and that can be a tedious task. So primary key helps you fetching the data as well as organizing the data in a particular fashion. Moving on, the second type of constraint is default constraint. So default constraint, as the name suggests, is used to give the default values to a particular column. This usually happens when the front-end application does not give any value to a column, and you should have a default value in order to maintain the integrity of the data. Suppose you have a column called quantity, and the front-end application has not supplied any values from the source. So in that case, what you can do is you can set the quantity to have its default value set to 0. So in other case, if you don't have any values coming from the front-end application, the data will not break down, or the application will not break down, and it will store 0 in the database. The third type of constraint that we are going to discuss today is a check constraint. Again, as the name suggests, it is like a check against the data that should be inserted inside a column. An example would be if you have a column that stores the email IDs of all the employees, or email IDs of any person, then you can apply a check that the email ID should be of type @abc.com. So in that way, if you try to insert any other value that is not of type @abc.com, it will throw an error, and same can be controlled with the help of check constraint. The fourth type of constraint that we are going to study is a foreign key. Foreign key is specifically used when we have relational tables. We'll be discussing this later in this video, but before doing that, let us discuss about the previous three constraints, and let us try to explain it with the help of a SQL script, because it's always useful to do the practical than the theory. So for the same purpose, what we are doing is we are creating a sales table that has got sales ID, product ID, client ID, quantity, and total as the column names. So you need to write the script to create the table, and the way to do is just by writing create table and then the table name and then the column name column type, and you need to specify whether it's a nullable column or a not nullable column, and then the constraint. So you need to remember this order. Firstly, you will have the data type, then you will have to specify whether the column is nullable or not, and then you should specify the constraint. If you do it other way around, it will throw an error. So what we have done in this case is we have said that the sales ID would be of primary key, and the quantity would have a constraint default which has the value set to 0. So this means that if you don't supply any values to this quantity column, it will have a 0 stored against it. And we are applying a check constraint for the column named total, and the check is that the total should always be greater than 100. So if you have the total lesser than 100, it will throw an error. Another thing that you might notice over here is that the total is of money type. Money is also a data type that is used in SQL. So if you have any column that stores currency from different countries, you can specify that column as of type money. So let's execute this statement. Once again, what you have to do is just highlight the query, and then you need to press F5, highlight it, and then press F5. So the command was executed successfully. So let's check whether the table has been created or not. So table has been created, but it does not contain any data because we haven't inserted any data into it. So for the testing purpose, what we are doing is we are inserting some values into the database using a single row. The syntax for the insert statement is like, you have to first write insert, then into, these are SQL keywords, then the table name, followed by the columns that you want the data to be inserted in. So we have a sales ID, product ID, client ID, total. We have excluded the quantity column because we just wanted to test whether it holds the default value or not. And then the values. Remember, the order of the values should be the same as the order of the columns that you specified in the insert clause. So after you have done that, just select the particular statement and click on or press F5. So it says 1 row affected. So as I told in the previous chapters as well, when we are talking about the insert and the delete statements or even the update statements, it gives you the messages such as 1 row affected or 2 rows affected, because it always applies the operation on row by row basis. So this is done. Now let's check the data inside the table. So you can see that the default value for quantity was specified as 0, and that is why we have a 0 in the quantity column, and rest of the values, they met the criteria and were inserted into the table successfully. Let's try to insert another sales ID of value 1. As per the primary key, or as per the rules for the primary key, the column should be unique and it should be not null. But what we are trying to do is we are trying to insert the same sales ID value that is already there in the table, and it should throw an error. Let's not disturb the total quantity as of now, or the total column as of now, and insert the sales ID 1. So you can clearly see that we got an error, and it says that violation of primary key constraint. So this means that it will not accept duplicate sales IDs. The sales ID should always be unique and not nullable. Now let's try to check the check constraint. So we have specified that the check constraint is on column total and it should have a value greater than 100. So what if we supply a value of 10, but before that let me introduce a new sales ID so that it's not duplicated and should not throw an error. So now when you select the statement and press F5, we got the message that the insert statement conflicted with the check constraint. So this is because we are specifying a value less than the value set out by the check constraint, that is greater than 100. Now if we replace 10 with 101, the value should be inserted without any error. So you can see it says 1 row affected. Now let's check the values inside the table. We need to press F5. So you can see that the rows have been inserted successfully, but before inserting, we need to make sure that they are not violating any of the constraints. So this is particularly important when you have a front-end application and you have some sort of rules applied on certain columns. For example, there could be a column that specifies the name. So name cannot be an integer. So can apply a check with the respective column inside the table that it shouldn't be an integer. So I mean, there are two types of checks you can perform when we work on any applications. One is at the front end and the other one is at the back end. So it's important to keep these two consistent, because if you apply the constraints or the checks in at the front end of the application, and if you don't apply at the back end, that is the database or the table, then redundant values might be inserted into a table, and which can lead to confusion or can say bad data. So in order to avoid these cases, it's very beneficial to apply the constraints on a table so that the data integrity is also maintained. So now that we have studied all the constraints, it's time to study foreign key constraint. And to study foreign key constraint, you need to understand the concept of relational database or relational tables. So it's very seldom that you have a single table inside a database. Database will be a collection of tables which are interrelated with the help of common columns. Why it is necessary? Because if you studied the normalization forms, it says that the data should be broken down into smaller chunks that are independent of each other and that can be stored in separate tables. And if you want the combined information, you can join these two tables, or you can fetch the data from these two tables with the help of common columns. So let us consider an example of employee and address. So what we have here is an employee table which has EID as the primary key and name as the other column. And then we are saying, or then we are creating a table called address which has EID, and this EID is referring, or it's coming from the parent table employee, and that is why we say that it's of int type and references employee table and EID column inside employee table. So this is nothing but creating a foreign key constraint. So what we are doing actually is we are maintaining a relationship, or we are creating a relationship between a table called address and a table called employee. Employee being the parent table and address being the child table. So whatever records that you have in the employee table will have certain entries in the address table. It may not be necessary that all the employee IDs should exist in the address table, but it is necessary that all the employee IDs should come from the employee table. So let's go ahead and create this. So make sure that the database is selected in the drop down as I mentioned in the previous videos. So just go ahead and highlight the statement and then click or press F5. So the statement has been executed successfully. So this means what we have done is we have created the structure for the employee table and the address table. Now it's time to insert some data into it. Okay, so the data has also been inserted. Now let's see the data, how it looks like. Press F5 for that. So you see we have three employees, 100, 101, 102, and then we have their corresponding addresses. Yeah, it can be possible that an employee may have more than one address. Just for the sake of example, don't go into the details. So you can see employee ID 100 or employee 100 having ID 100 has two rows. Similarly, 101 has three rows and 102 has a single row. So let's try to test whether we can insert an employee ID in the child table address that does not exist in the employee table. So for that we will do insert, or we will write insert into address values. So let's say we are inserting 103 value, and you can specify any address, and you can specify any state. So let's go ahead and execute this. You need to highlight it first and then execute. So see, we got the error message that we are violating the foreign key constraint. So I hope you get this. Foreign keys are very important when we have a relational database, because without foreign key, the relationship between two tables cannot be established. So it's very important to understand the concept here. Just keep in mind that when we have foreign key constraint, you cannot insert values in the child table that are not there in the parent table. So we'll now move on to the other important concept of joins.